So this is tutorial 3 for Vibrational Dynamics, and it's based on the content for chapter 2b. So we have a simplified model of a passenger car travelling over a road and vibrating in the vertical direction. Okay, the mass of the vehicle is 1,000 kilograms, the spring stiffness of the suspension is 500 kilonewtons per metre, and there's a damping ratio of 0.5. And part A says determine the damping coefficient of the suspension system. So we've got to work out what C is. So part A, we know that the damping ratio is the damping coefficient divided by the square root of mk times by 2. Okay, so we can rearrange this equation to get C is going to be 2 zeta root mk, and we plug in the numbers. So we've got 2, 0.5 square root of m, which is 1,000, and k, which is 500 times 10 to the 3. And we do the sums, and you get 22.36 times 10 to the 3 Newton seconds per metre. Okay, part B says what is the quality factor of the system. This is the quality of oscillation, and if you look at your notes, Q was 1 over 2 times zeta, which is 0.5, and so that's 1 over 1, so we have a quality factor of 1. Part C is work out what lambda is, which is the logarithmic decrement, and again, looking at your notes, we have an equation, 2 pi zeta divided by root 1 minus zeta squared. So again, plugging in the numbers, gives us 3.6276. Now part D says if the road surface is oscillating with assumed to be a sinusoid over a length cycle 1 of 6 meters, so this is 6 meters, this distance, okay, such that the force amplitude, which is this thing here, is 12.5 kilonewtons, determine the displacement amplitude of the vehicle if the vehicle is travelling 30 meters per second. Okay, so we need to work out, obviously we've got an equation, the amplitude is f0 divided by k, and we've got 1 divided by the square root of 1 minus r squared plus 2 zeta r squared, where r is omega divided by omega naught. Okay, so we need to work out what omega naught is. Well, omega naught is equal to degree of freedom root k upon m, so that's 500 times 10 to the 3 divided by 1 times 10 to the 3, and we get a frequency of 22.3607 radians per second. Okay, for omega we need to work out the cycles per second and convert to radians per second. Okay, well, it makes sense that the frequency in cycles per second is going to be the velocity divided by the wavelength, which I'll call L, and so that's going to be 30 meters per second divided by 6 meters is going to be 5 hertz. Okay, omega is 2 pi f, and so we get 10 pi, which is 31.4159 radians per second. And so R is going to be 31.4159 divided by 23.3607, which comes out to be 1.405. And so if you plug in the numbers now, A is going to be 12.5 times 10 to the 3 divided by K, which is 500 times 10 to the 3, 1 over 1 minus 1.405 squared, all squared, plus 2 zeta, which is 0.5, and then we've got 1.405 squared rooted. And if you do that sum, that should come out to be 0.0146 meters. So 14.6 millimeters. Part E, C T3.m on Blackboard.